All right, so we're doing section 13.9. This is the last section, I believe, isn't it? Yep, this is the last. Well, it's actually the last section of the book, but we got to go back. Do you remember we skipped a couple?
Yeah.
We skipped 4 and 5, I think, and that's law of sines, law of cosines. We'll do that right at the beginning of next week. Okay, so it's looking like if we finish that at the beginning of next week, it's looking like maybe towards the end of next week having a test. Okay.
Are we turning our homework?
6 and 7.
6 and 7.
Yeah, 6 and 7. All right, here we go. Let's now talk. Now we know how to do this stuff already. If I gave you 30 degrees and I say what's the, I don't know, let's just do the sine. What's the sine of 30 degrees? So what you're doing is you're looking at this, absolutely, you're thinking. You're thinking about this situation right here, or you could jot it down. That's fine too, right? And then you say, what's the sine? It's a half. All right? But what we're doing something a little different today. We're acting like we don't know what the angle is. So I'm going to write sine of what? What would I call that if I didn't know what it was?
Theta.
Call it theta. Or you could call it x. It doesn't matter. They're interchangeable, basically. Equals a half. So what we want to do is we want to find what angle, if I take the sine of it, am I going to get a half? Well, obviously, I've got the picture right here. So what would one of those angles be? It'd be 30 degrees, wouldn't it? Okay, because the sine of 30 degrees is a half. Now let's think about this. Is there any other place on here where the sine is actually equal to a half? Positive. Oh, no, I almost put a negative there. I'm so used to doing it. Positive 1/2. Is there another place? Is that the only place? Yeah, second quadrant. Look at that. Because if I come over here, what would that angle? Oops. Trying to draw it. It's supposed to be the same degree as that. You get the idea. So that's 30 here, but the whole thing is what? It's 150. And that sine of 150 is also a half. So I could say 150, couldn't I?
Could you also say like 390?
Exactly right. That's the next point. Watch. You could go all the way around the circle once and then back up to 30. So you could say 390. Talk to me. Then you could do what?
Go around.
Yeah, go around. So what? I could keep adding 360 all day long, couldn't I? What's 360 and 150? What's that?
510.
510? Okay.
Can't you go clockwise and say
Yeah, I could put negatives in there. I could do all that kind of stuff. But let's just stick with positives right now. But I could keep doing this forever, couldn't I? I mean, literally forever. Because I could keep adding a 360, 360, 360 is until whatever forever is, okay? But that would be ridiculous, wouldn't it? What we want to do is we want to narrow it down so that we only have one answer. Okay, we got to set up some restrictions. So one of the restrictions is, well, let's go at least around the circle just one time. Okay, we're gonna get rid of that whole option of going around the circle a whole bunch of times. So that's gonna knock that out. It's gonna knock that one out. Does that make sense? We also want some restrictions where we only get one answer. I don't want two. Which one do you think you would rather have, the 30 or the 150? What's that?
32 angle probably.
Yeah, probably the 30. Okay, because that's like the, what do we call that? The, not the terminal. I guess I don't know. There's probably a word for it, but yeah, we probably want the smaller one, wouldn't you think? All right, so we'd probably want that angle right there. So we have to figure out some restrictions so that we only have one answer to this. Does that make sense? I don't want two answers. I just want the one answer. So we have to set up a level of restrictions here. Now what we're going to do is we're going to set up, I'm just going to draw this by hand, not use the straight line tool because I don't have to be precise with this at all. Of course we have 4 quadrants, don't we? These are the restrictions for theta, all right, or x if you want to call it x, for our angle when we're doing these things, when we're trying to find what this is equal to. Here's our restrictions. For the sine and the tangent, okay, it's just the sine and the tangent. They have the same exact restrictions. So again, we can't go around the circle a whole bunch of times, but we want to restrict it to a certain number of quadrants. We're going to restrict it to 2 different quadrants. Sine and tangent are restricted to the first quadrant and the 4th quadrant. Now, if you look in the book, they don't say it like this. I do it like this because I think it's a little easier to remember and to visualize. They say, I believe they say, the restriction is between pi over 2, and let me just look to see what they say.
They do it in reading.
Yeah, they say it's between pi over 2 and, or negative pi over 2 and pi over 2. But you know what that means, right? Basically, they're saying this. From negative pi over 2 counterclockwise to pi over 2. All right, because that's the way we normally travel, right? So that's our restriction right there. Yep.
Wouldn't that be for the cosine?
No, I'll show you why. I'll show you in a second, okay? So that's for the sine and the tangent, all right? So it's between the negative pi over 2 and in this direction pi over 2. Now, you'll see this in the book. That's why I wrote it down. But when I think about it, I just think between the first and the fourth. Plus, the arrow helps me out. So the sine and the tangent, when I'm doing these are going to be inverse functions, and I'll show you in a second. We're restricted to only these two. So I'm going to mark out this one, and I'm going to mark out that one. All right, so I'm not using these two quadrants at all. I'm only using the first and the fourth. All right, for instance, watch. If I did the sine, right here, let's do the one we did. The sine of 30 degrees is a half, right? So that's the between these restrictions, because what if I went down here 30 degrees? Then the sine wouldn't be a half. What would it be? It'd be negative a half. So really, I've narrowed it down. Even though I've restricted myself to two quadrants, the sine's only going to be in one of these two quadrants. Would you agree? All right. I don't restrict it between here and here, because look, if I restricted it between the first and the second, then the sine is a half here, the sine is a half here, I still get two answers. I don't want two answers, do I? All right, same thing with the tangent. Think about it. If I said, and by the way, I should have written, I'll tell you what, let's do this. Let's get theta by itself. And you probably remember this, not terminology, but this way of writing it. So if I wanted to solve for theta, theta is equal to the inverse sine. Do you see that? So if I'm solving for theta, it's the inverse sine of 1/2. Now, this is a little bit picky, but let me just tell you real quick here. It's not that huge of a deal, but when it's a little s, there's really no restrictions. You put as many answers as you want when it's a little s. When it's a capital S, which is what you're going to be seeing in these homeworks, okay? When it's a capital S, or C for cosine or T for tangent, okay, when it's capital and it's an inverse function, that tells you, that's like a little symbol. It's like a little, what would be a good way to say it? It's just, it's a way for them to tell you that, okay, if I'm using a capital S, I'm restricted between these two quadrants, okay? If it was little s, then I could put as many answers down as I wanted to. Does that make any sense? But when it's a capital, I'm only going to have how many answers if it's a capital S? One answer, okay? So if it's a capital S, my only answer would be 30 degrees. Okay? It's kind of just, it's just the way they write it. It's their, you know, it's their subtle little way. Instead of saying all the time, okay, well, let's restrict this one and not restrict this one. The capital means we're going to restrict it. Let me show you another way you can write it, which means the exact same thing as this, okay? Looks a little weird, but it means the same exact thing. I'm not sure the history of this, but watch. If I put the word arc before the sign, now I can just put a little s now since I have the arc. Now notice the arc has a big, it's a capital A. That means we're going to be in our restricted areas, okay? We can't go around the circle a whole bunch of times. We're going to stay in our restricted area. So if I said arc sine of a half, if I saw this and it said, find it, well, what does that mean? This means the inverse sine of a half, which means where in the world, if I take the sine, what angle, that's what I should say, what angle, if I take the sine of it, am I going to get a half? Well, obviously, we've talked about this already. Where would that be? It'd be at 30 degrees, okay? And so your answer would be 30 degrees. Does that make any sense at all? So this is our, man, I'm trying to think of this one word, and I just can't think of it. These two things mean basically exactly the same thing. Just two different ways to write it, and you'll see it. I think they vary it from question to question. Sometimes they'll write it as the inverse, sometimes they'll write it as the arc. But just understand, it means the same thing.
So, Mr. Herring, the difference between arc sine and cosecant is with cosecant, they give you an angle.
That's right.
And you give them the ratio. But with arc sine, they give you the ratio.
And you give them the angle. Exactly right. Yeah, exactly right. Did you hear that? So on this one, look, they're not giving you an angle, are they? What are they asking for? They're actually asking you to find what? The angle. Okay, they want you to find the angle. So when it's inverse sine or arc cosine, arc tangent, all that kind of stuff, when it's that, they're asking you to find an angle. And that's what our answer is going to be. Notice, it's an angle, isn't it? Okay? Just real quick, before we move on to the next slide, let's do the restriction for the cosine. All right, so this is the restriction for the cosine. We're only going to deal with the first and the second quadrant. We're not dealing with the third. We're not dealing with the fourth. Let's see why. Because let's just use 30 again since we've been talking about 30. what's the cosine of 30? It's the square root of 3 over 2. See, I would not restrict myself to this, the first and the fourth, because in the fourth quadrant, the cosine is exactly the same thing as it is in the first quadrant, isn't it? All right. So I want it to have two different possibilities. So the first quadrant, the cosine is positive square root of 3 over 2, and in the second quadrant, the cosine of 30, or in this case 150, would be negative square root of 3 over 2. All right. So I need two different possibilities for my answers. That's why I'm restricted between the first and the second. Let's go to the next slide, and we'll do some more stuff with this, do some examples with this. Okay.